How can a whisper survive the emptiness between stars? To even imagine such a thing is to contemplate the limits of what is possible for humanity's ingenuity, curiosity, and resolve. Yet, at this very moment, at the shadowed edge of our solar system, a lone spacecraft, Voyager 1, drifts silently, more than 15 billion miles from the only home it has ever known.
Voyager 1 is no more than the size of a compact car, roughly comparable to a small hatchback you might see parked on any city street. Its exterior is a spindly tangle of antennas and booms, its body a squat, boxy frame, assembled with the tools and know-how of the late 1970s. The electronics inside are astonishingly simple by modern standards. Voyager's main computer has less processing power than a basic digital wristwatch today. Yet, against every expectation, it still talks to us.
15 billion miles. To put it in perspective, if you could somehow drive a car at 60 miles per hour, day and night, without ever stopping, it would take you more than 28,000 years to reach Voyager 1. That is more than the entirety of recorded human history, multiplied many times. It is a distance that defies comprehension, a number so vast that even light itself takes more than 22 hours to make the trip from Voyager back to Earth. It is the furthest any human-made object has ever traveled, further than the orbits of Pluto and Eris, out beyond the grasp of our sun's magnetic field, and into the yawning abyss between the stars.
The signal Voyager 1 sends out is so faint that it is almost inconceivable. By the time its radio waves reach Earth, they have been stretched and diluted by the vastness of space until they are weaker than a whisper, fainter than a sigh, nearly lost in the cosmic noise that fills the universe. Each message has to cross a void so immense, so empty, that it is a miracle anything at all arrives. The spacecraft's radio pulses are almost erased by the static of cosmic radiation and the infinite distance they traverse. But still, on Earth, our largest and most sensitive radio telescopes, the Deep Space Network, stretch their ears as wide as they can, listening for the faintest heartbeat in the darkness. Against all odds, they hear it. After decades in the dark, Voyager's voice still finds its way home.
What Voyager beams back is more than science. It is a fragile link to the edge of everything, a living thread tying us to the most distant known place. Each transmission is a tiny miracle, proof that human curiosity can outlive expectation and cross impossible distances. A humble machine, now our furthest ambassador, carries our questions and hope into the unknown. But time is running out. Every year, Voyager's power wanes. Instruments shut down, one by one, falling silent. Soon, the very last message will fade, and our connection to Voyager 1, our voice at the farthest edge, will be gone forever. When that happens, we will lose more than a spacecraft. We lose a living symbol of endurance, of what it means to reach beyond the possible. Voyager 1 was never supposed to last this long. Its original assignment was modest, a brief journey of 5 years to explore Jupiter and Saturn, then silence. Its designers planned for it to send back data and photographs, then to fall forever mute, its batteries drained, its voice lost to the void. Instead, it has survived nearly 5 decades, enduring radiation storms, the freezing dark, and the endless reach of interstellar space. The spacecraft's heart still beats, its ancient circuits still blink to life, answering signals from home. In a way that no one dared to hope, it is alive. How did this delicate machine, built nearly half a century ago, persist and keep speaking from the darkness? What does it take to hear a messenger at the edge of forever? To find the answer, we must return to Voyager's beginning and the rare cosmic alignment that set its journey in motion. To understand how Voyager 1 defied every prediction, we need to look back to its improbable birth. The story begins with a chance that would not come again for more than 170 years, a window of opportunity that echoes other moments in history when timing and vision converged. Think of the rare alignments that enabled the construction of the Egyptian pyramids or the building of the first transcontinental railroad. In each case, a fleeting moment of possibility was seized. Voyager 1 was never built to be a legend. Its creation was quick, its budget modest, and its circuitry simpler than what hides inside your digital watch. The mission was meant to be routine. Launch, survey some distant planets, then vanish quietly into the void. No one at NASA imagined it would become humanity's most distant voice in the dark. In the summer of 1977, NASA launched 2 spacecraft, Voyager 1 and its identical twin. Their prime targets were Jupiter and Saturn, gas giants that no probe had ever studied up close. The plan was straightforward: collect scientific data, capture images, and let the Voyagers drift quietly into the endless black. But this mission wasn't possible just any year. There was a fleeting cosmic window, one that opens only once every 176 years, when the outer planets align just right. This rare arrangement allowed the Voyagers to use a gravity assist, slingshotting from planet to planet, stealing speed from their massive hosts. Picture a game of interplanetary billiards, where each planet's gravity adds momentum, flinging Voyager onward at a pace no rocket fuel could match. It was a cosmic trick that transformed an impossible dream into a mission NASA could actually afford. Yet the technology was astonishingly primitive. Each Voyager carried about 78 kilobytes of memory, barely enough to hold a single modern photo. Data was stored on 8-track tapes, the kind most people had already left behind. The onboard computers were weaker than the cheapest digital watch today. But every component was chosen for one thing: survival. This method, called gravity assist, was first used in a limited way by the Mariner 10 mission to Mercury in the 1970s, but Voyager would take it to an unprecedented scale. The mathematics involved was so complex that only a handful of scientists could calculate the precise paths required. The alignment itself would not reoccur for nearly 2 centuries. Had NASA missed this window, the mission as we know it would have been impossible. The designers drew inspiration from robust, time-tested technologies. For example, the spacecraft's main computer was based on the RCA-1802 microprocessor, a chip so simple that it could be made resistant to cosmic rays by sheer redundancy. The systems were built in layers, with backup upon backup, a design philosophy reminiscent of early aircraft engineering, where mechanical reliability could mean the difference between life and death. Each wire, screw, and circuit was tested to withstand the cold, the heat, and the radiation of space. The goal was not glamour, but endurance. Voyager was more than a machine. Each carried a golden record, a copper disc covered in gold, etched with voices, music, and images meant to portray Earth's diversity. Greetings in 55 languages, songs from ancient times and modern ones, photographs of landscapes, cities, and people. It was a hopeful gesture, a message in a bottle tossed into an ocean no human could ever cross. Still, no one expected much. Engineers hoped the spacecraft would last 5 years, 10 if fortune smiled. After that, they expected only silence. Almost no one dared imagine that, nearly half a century later, Voyager would still be speaking to us from the edge of the unknown. But Voyager's journey was only just beginning. What lay ahead would test not just technology, but the limits of human imagination. What happens when a machine endures beyond every expectation? What does it witness as it drifts ever deeper into the unknown? This golden record was the brainchild of a small team led by astronomer Carl Sagan. They selected content that would serve as a snapshot of humanity, from the music of Bach and Blind Willie Johnson to the sound of a baby's cry, the roar of thunder, and the greetings of children. In a sense, the golden record is our cultural DNA, a time capsule intended for anyone or anything that might one day find it. Imagine if, centuries from now, a distant civilization were to discover Voyager drifting through their region of space. That ancient message would be their first introduction to Earth and its inhabitants,
a poetic hope that echoes humanity's oldest stories of casting treasures into the sea. Voyager 1's Odyssey challenges the boundaries of what we believe is possible. Sometimes, tools built for a single purpose outlive their makers and their missions, becoming legends that redefine our sense of what endures. Consider the ancient Greek Antikythera mechanism, a sophisticated clockwork computer lost for centuries beneath the sea, or the Roman aqueducts still standing after millennia. Like these, Voyager has become a symbol of endurance far beyond its intended lifespan. Voyager 1 began with a modest task: fly past the largest planets in our solar system, take a few photographs, and then slip quietly into the dark. Instead, it became an eyewitness to wonders no one dared predict. Its journey rewrote the story of our cosmic neighborhood, forever changing what we believed about the worlds beyond Earth. At Jupiter, Voyager 1 shattered our assumptions. Its cameras caught fiery eruptions on Io, a moon once dismissed as frozen and dead. Suddenly, we saw geysers of molten rock and sulfur shooting hundreds of miles high. Jupiter itself, once just a massive ball of gas, revealed raging storms, swirling cloud bands, and hurricanes larger than Earth itself. Then came the unthinkable. Jupiter has rings. Not the brilliant hoops of Saturn, but pale, ethereal bands, barely visible and utterly unexpected. Voyager's images forced scientists to rewrite textbooks overnight. The planet we thought we knew was far stranger than imagined. Take Io, for example. Before Voyager, scientists believed it to be a cold and inert moon, a relic of the solar system's formation. But Voyager's images revealed active volcanoes, the first ever seen on another world. The discovery upended our understanding of geology and planetary science. It proved that moons could be as dynamic and alive as planets themselves, driven by tidal forces and internal heat. Voyager also discovered intricate details in Jupiter's Great Red Spot, a storm so vast that 3 Earths could fit inside it. The spacecraft's instruments measured the planet's magnetic field, revealing it to be 10 times stronger than Earth's, with radiation belts intense enough to fry unprotected electronics. These were not idle facts. They changed the way we approached future missions, such as Galileo and Juno. When Voyager reached Saturn, the surprises multiplied. Its instruments revealed not a few rings, but thousands, each a separate band, carved by unseen forces and shepherded by tiny hidden moons. Among Saturn's retinue, Voyager discovered new worlds, including mysterious Titan. Wrapped in thick, golden haze, Titan became an obsession for scientists dreaming of life beyond Earth. The outer solar system was not a silent graveyard, but a realm pulsing with energy and weather, crowded with secrets. Voyager showed us that these distant giants are alive, with storms, atmospheres, and moons that defy imagination. Each flyby forced us to admit how little we truly knew. The images sent back showed Saturn's rings as a complex system of gaps, waves, and braids shaped by the gravitational tug-of-war with its moons. The so-called spokes in the rings, mysterious dark features, appeared and disappeared with the planet's magnetic field. Voyager's findings inspired decades of research, eventually leading to the Cassini-Huygens mission, which would drop a probe onto Titan's surface more than 30 years later. After its historic encounters, Voyager's mission changed forever. Its cameras were turned off to save the last drops of power. It left the familiar plane of the planets behind, coasting toward the sun's final frontier, the edge of the solar system, where sunlight fades and the unknown begins. For decades, it pressed onward, and in the year 2012, Voyager 1 became the first human artifact to cross the heliosphere, plunging into true interstellar space. Every mile brought new dangers. The farther Voyager traveled, the fainter its signal grew. A single glitch, a stray burst of radiation, or a grain of cosmic dust could spell the end. The risk was existential, not just the loss of data, but the extinguishing of humanity's outpost in the great emptiness. Yet Voyager survived, outlasting all predictions. Its ancient voice continued to whisper across billions of miles, braving the most hostile and silent expanse ever explored. It defied both the limits of technology and the passage of time. Crossing the heliopause, the boundary where the sun's influence gives way to the interstellar medium, was a milestone as momentous as Magellan's circumnavigation of the globe or the Apollo astronauts landing on the moon. For the first time, a human-made object had left the protective bubble of our solar system and entered the realm between the stars. The data Voyager sent back showed a dramatic change in cosmic particle density and magnetic fields, confirming that it had indeed crossed into a new domain. But as Voyager slipped ever farther from home, a new question surfaced. How do you keep speaking to a spacecraft built in the 1970s, now farther from Earth than any object in history, and still receding into the dark? Every message sent to Voyager 1 is a wager, a fragile conversation with eternity, always shadowed by the risk of final silence. Maintaining contact with Voyager 1 would demand ingenuity as remarkable as its journey itself. The challenge was not just technical, but a test of human resolve and imagination. More than 15 billion miles from home, Voyager 1 broadcasts a radio signal powered by only 22 watts. That energy, barely enough to light a refrigerator bulb, travels across a gulf so vast the signal is fainter than a trillionth of a watt by the time it brushes Earth's antennas. Catching that cosmic whisper is not luck, it is relentless pursuit. Reception is a high wire act. The antenna must be aimed flawlessly, not merely close. If Voyager drifts even a sliver of a degree off course, the link could vanish forever, our voice erased from interstellar space by an invisible slip. Yet, even when everything aligns, patience is required. Data arrives agonizingly slowly. Imagine waiting hours just for a handful of bytes, each byte containing scientific gold from a realm no other probe has ever touched. These are not just facts. They are messages from a place no human eye will ever see. Enter NASA's Deep Space Network. Across 3 continents, Australia, Spain, and the United States, immense dishes stand sentinel, scanning the heavens for Voyager's dying signal. Each antenna is 70 meters wide, roughly the length of a football field. These are some of the largest movable objects humanity has ever built, engineered to detect the faintest murmurs from beyond the solar system. Timing is everything. Communication windows are measured to the minute. Miss one, and you risk losing a precious chance to hear from the edge of the unknown. So the question remains, how does Voyager keep holding on? And what are the engineers on Earth doing right now to drag every last signal from the cosmic dark? Meanwhile, Voyager's systems limp on in a battle with time. Power dwindles, memory fades. On Earth, engineers become digital surgeons, sending remote fixes to a spacecraft built before the internet was even conceived. They have rewritten code, reprogrammed memory banks, coaxed sputtering thrusters back to life, and performed miracles on hardware older than most of those who care for it. Every problem solved buys another precious day of discovery. For example, in 2020, Voyager 1's attitude control thrusters began to show signs of wear. The spacecraft was having trouble pointing its antenna precisely at Earth, a critical failure that would spell the end of communication. The engineering team, drawing on decades-old manuals and ingenuity, devised a fix. They switched to a backup set of thrusters that had not been used in 37 years. It worked. The signal was restored, and Voyager's journey continued. But the threat is always close. At any moment, contact could be lost, shutting our only window onto the interstellar frontier. With it would vanish a living chapter of humanity's story, and our sole direct measurements of what lies beyond the sun's reach. Each message received is a small triumph. Each silence, a reminder that the thread connecting us to Voyager could snap without warning. Survival in deep space is never simply a matter of brute force. It is adaptation, careful stewardship,
and the quiet ability to change as the universe demands. Voyager's endurance is the product of both brilliance and desperation, a testament to what happens when human determination refuses to let go. But as its systems weaken, the mission faces new, unprecedented threats. Every watt counts. The team must decide which instruments to silence, which to keep alive, how to stretch the shrinking supply further than anyone imagined. Shutting down a heater risks a system freeze. Turning off a sensor means losing a vital sense forever. These are not just technical choices, they are sacrifices. Voyager's endurance in the frozen dark is not a miracle. At its heart beat 3 radioisotope thermoelectric generators fueled by the slow fire of plutonium. These ancient cores lose strength day by day, their power dwindling with the steady, inevitable decay of atoms. Each sunrise on Earth means a little less electricity, one more hard choice for the engineers. Most of those guiding Voyager now are younger than the spacecraft itself. To them, Voyager is not merely machinery. It is a patient in a perilous condition, surviving against all odds. Each decision is laden with risk. A single wrong command could plunge Voyager into silence, from which it will never return. As years pass, more of Voyager's eyes and ears go dark. Yet the mission refuses to surrender. Engineers reroute power along new paths, reprogram code so old it predates many of them, and invent fragile workarounds that squeeze out another day, another data packet. What began as late-night hacks has become ritual, a daily devotion to keep Voyager's heart beating. The dangers are mostly invisible. Cosmic rays flipping a single bit in memory, voltage drops threatening to wipe out decades of data, thrusters clogging after 40 years of use. Each threat is met not with panic, but with patience and stubborn creativity. There are no quick fixes left, only the hard-won art of keeping old things alive. Practical steps abound. For example, each year, engineers meet to triage Voyager's remaining systems. They prioritize instruments that can provide unique data, such as the cosmic ray detector or plasma wave sensor, and reluctantly power down others. They update tables of commands sent to Voyager, sometimes adjusting for the delay in signal travel, sometimes reprogramming to account for failing hardware. Communication protocols must be reviewed and revised as the spacecraft's memory degrades, and backups are maintained in case of unexpected resets. Sometimes, new threats appear with little warning. In January 2023, a data issue caused Voyager 1 to send back garbled information. Engineers traced the problem to a faulty memory location and quickly devised a workaround, rerouting data through a different pathway in the spacecraft's computer. This kind of real-time problem-solving is reminiscent of the Apollo 13 crisis, when ground crews worked around the clock to save the crew. With Voyager, however, there are no lives at stake, only the life of a machine and the hope it represents. Voyager teaches us that legacy is not measured by dazzle or raw power, but by endurance and care. Progress is not always found in racing forward. Sometimes it lies in extending the life of what we have already built, daring to believe it is still worth saving. The greatest tool the team wields is not technology, but empathy. The belief that even a failing spacecraft can still matter, still speak for us across the abyss. If we chase only the newest and brightest, we risk losing our best selves, the wisdom, the stories, the hard-earned achievements that time alone brings. Voyager proves that meaning grows from purpose and devotion, not just specifications and speed. Its survival honors both engineering and humanity's quiet capacity for patience. As the last whispers from Voyager drift across the stars, we are left with a question. What does it truly leave behind? What has its long journey taught us, not just about the universe, but about ourselves, and about what we choose to remember? One day, Voyager's voice will go silent, yet its message will outlast us all, drifting through the dark between stars. Voyager's story does not end with silence.
Even as its signal fades, the legacy it leaves behind continues to echo, inviting us to reflect on what endures and why we strive to send messages into the unknown.
For more than 4 decades, a fragile probe, born from 1970s technology, less advanced than a digital watch, has defied every boundary we imagined. It crosses the void, farther from home than any other creation, guided not by endless power, but by purpose, and by the hope that someone, or something, might one day hear its call.
We started with a single audacious question. How can we reach so far, for so long, with so little? The answer is written in each worn circuit and every faint relay. What matters most is not technology's edge, but the care we give, the ingenuity to repair and adapt, and the persistence to keep reaching into the unknown. Voyager is more than a machine. It is the echo of our curiosity, our courage, and our longing for connection. Across billions of miles, it carries the laughter, music, and dreams of a world it can never return to, a world that might one day forget its own message, but whose hope persists on a golden record, spinning silently between the stars. But nothing lasts forever. The signal will fade. The tiny power source will cool, until Voyager's instruments fall silent, leaving only its unending journey through the cold dark. When that happens, we lose our last direct link to true interstellar space, a thread finally cut. What are you sending out into the world? What echoes will you leave behind? Voyager's path reminds us that our finest work may outlive us, surviving on tides of time and chance, touching lives we will never meet. Yet, letting Voyager's story end here would overlook what truly matters. Our refusal to stop sending messages into the dark, not for reward, but for wonder itself. If we stop reaching, stop risking, stop believing our voices matter, we surrender the very trait that sets us apart among the stars. So as its signal dims, take a moment to listen. Voyager is only one fragile artifact, but in its long journey, it offers a challenge. Care for what you create. Stretch the lives of your dreams. Keep asking questions, even when no one seems to hear. In the centuries to come, long after our names are forgotten, Voyager's golden record will still wander among the stars. It is a testament not only to what we have built, but to who we are, a species that dares to hope, to persist, and to send our whispers into the silence, trusting that someday, somewhere, someone will listen. That is how a whisper survives the emptiness between stars, not by the strength of its signal, but by the depth of its meaning and the courage of those who send it.